So today we're going to see about mining of massive database. So here mining of massive data sets means it's a process of using a special computer programs, statistics and machine learning to find a hidden patterns, trends and useful facts inside giant piles of informations. For example, just think of it like washing tons of dirt and rock to find a small piece of gold. So this is the mining of massive data sets. The core concept includes finding a patterns, handling big scales, stream processing, making predictions are the core concept in mining of massive data sets. In real time examples are recommendation systems. For example, services like Netflix or Amazon look at what millions of other people watch or buy to suggest things you might like. So next is web search and ranking. Here the search engine plays a major role. For example, we use link analyzers for paging the rank. That is, we call it as a page rank to figure out which web pages are the best and most trustworthy to show you first. So this is a example for web search and ranking. Next is fraud detections. Bank scans millions of cards swipes every second to spot unusual behaviors. That means a card was stolen. So these are the real-time example of mining of massive data sets. Next, here, first we have to know about data mining. So, data mining means knowledge of extracting from large amount of data. So, this is we call it as data mining. For, that is also to find the hidden patterns, trends, and useful facts. So the main techniques are associations, classification, clustering, and regressions are the basic main techniques in data mining. So here we use a KDD process. That KDD is nothing but knowledge discovery from data. For example, if we take weather forecasting, for weather forecasting means we predict the result about the weather, cyclone and so on. So how it is generated? By applying the basic data mining concept. From where we take the weather data set. So the weather data sets are collected from meteorological data sets. So meteorological data sets means it's nothing but a meteorological mining. So sometimes we take it as a satellite, radar, balloon, and weather stations. So how we consider the data? Data means that parameters. The parameters are temperature, dew point, wind direction, wind speed, cloud cover. These are the parameters considered for weather forecasting data sets. So they have more applications in data mining. The applications are healthcare applications, finance and banking sector, scientific analysis, education sector, transportation, basket analysis, business transaction, fraud detections, research, and weather forecasting. These are the various applications where the data minings are used. Next is statistical model. So why we use statistical modeling? Is statistical modeling is important? Yes, of course. If you want to find something, or if you want to show something to others, so statistics is the best method to represent the actual things. Nothing but the process of explaining or predicting the functional relationship between the two variables. The two variables nothing like x and y variables. So here it has two parts. One is conventional programming, next one is machine learning. In conventional programming, we know the logic of the programming. Based on the logic, we programmed and feed that into computers, and finally we get the output for that. But in machine learning, we have a problem, and we know how to solve the procedure, but we don't know the logic, and we could not able to do the program. For example, in some department stores have a billing system software, so that is also one of the main example for machine learning. So next one is that we have some limits on statistical and data mining. The main problem is discovering unusual events hidden in the massive amount of data. To overcome the above problem, we use Bunfarani's principal method to solve the above problem. We use the control like family-wise error rate. This is family-wise error rate is the probability of incorrectly rejecting the true null hypothesis. The family-wise error rate is equal to 1 minus alpha. Here the alpha is 0.05. So we subtract the alpha values by using the family-wise error rate formula. So based on this, here we are accepting that there is a 5% of chance of obtaining the false positive results. Like if we here they have five types. First one is TF-IDF measure of word importance. That means, for example, if we consider a Word document, in that Word document, we going to search one particular keyword from the entire document. So for that, we use this function TF-IDF measure function to calculate the number of occurrences in the word in that particular document. So we will see about this in upcoming topics. Next one is hash functions and their uses. Third one is secondary storage. Fourth one is the base E of natural logarithmic and identifies involving that constant. And last one is power loss. So first one we going to see about the importance of word in documents. So for this, we use TF and IDF measure of word importance functions. So, what do you know about the importance of words in document? So that means, I already I told in the TF IDF measures, if we search some word, that is we use it as a keyword. So in that entire document we have two types. Either we do it in manual or do it in some programmatic way. So just think about it. We find the word in that document in manual way. How we will find? We first we will do uh, uh, we take the Word document. First, we will count the number of pages. Based on that pages, we segregate the pages for searching that particular keyword. So one method is manual method. Next one is by using a TF-IDF measure, we can find the number of occurrences of that particular word in that document. So we use two methods. So importance of words in document means it is faced with the problem of categorizing the documents. Categorizing the documents means nothing like a sequence of words by their topic, identified by finding a special words that categorize a document about that particular topic. A particular topic means what we going to search by using the keyword. So in a programmatic way, how to measure the word means we by calculating a TF and IDF. with this term, we calculating the number of occurrences in particular word in that document. TF means nothing like term frequency. IDF means inverse document frequency. So we compare term frequency times with inverse document frequency. First, we're going to calculate TF. So TF nothing but term frequency. Suppose we have a number of document. We first calculate the number of occurrences and number of words in that document. First, that for that n documents is equal to f of ij. Here f nothing but frequency. The frequency means number of occurrences. Next one is I and J. Number of word we consider as I in that particular document. So that we consider as J. So term frequency is equal to f of ij divided by max of k f of kj. That means number of repository of words in document by number of words in sentence. So by using this formula, we calculate the TF. So next one, we calculating the IDF. So IDF means we already saw what is inverse document frequency. So suppose I appears n of I of the n document in the collection. Then IDF is equal to log of 2 n divided by n of I. That means number of documents divided by number of documents containing the word. Finally, we calculate the TF into IDF, the term with the highest TF IDF score. For example, here we taking a 3 sentence. First one is good boy, second sentence is good girl, sentence 3 means boy, girl, good. So here we have to find TF and IDF value. So first we going to take how many words in this, common words in this 3 sentence. So here the good repeating 3 times, the boy repeating 2 times, and the girl repeating 2 times. So total number of the sentences 3. So we going to do, first we going to calculate TF uh, by using the above formula, and after calculating the TF we have to find the IDF value by using the above formula. That means log of 2 n divided by n of I. Next one is hash functions. Hash functions, it consists of plain text. Second one is encrypt password using encryption and decryption key. Third one is hashed value. So first one is plain text. The plain text is considered a most and safe option since anyone in the company can view your password. If, for example, if you we have in company we have a common system. In that common system, we just in desktop we just saved all our company's password and some files in that desktop. So the system password is known to all. So what we will do, so anyone can access that password or that particular information. So it is very easy to gather information, no security, and website owner can read your password. So here the no security wise it will be very poor, and if we using some website means the website owner know the password about what we used to log in. Next one is encrypt. So encrypt means we use two concepts here. One is encryption, next one is decryption. This is more secure than the plain text. So first what we will going to do is, if we have some data means we decrypt that data and send that data to the customer. The customer have the key to decrypt that encrypted data. So this is more secure compared to plain text, because once the decryption key is hacked, all the encrypted passwords are broken. There is a disadvantages in this encrypted password. Next one is hashing. It is not revealing a password in the data breach, because no encryption key is needed. Website owner cannot read your data. It is most ideal way to store your password. Hashing. A hashing means it efficient way to reduce the number of comparisons. It deals with the ideas of providing the direct address of the record where the record is directly to store. This is hashing. The hash table means it has two concepts. One is hash table, next one is hash function. The hash table means it is a data structure used for storing and retrieving the data quickly. Each entry in the hash table is made using hash functions. The hash function nothing like used to place data in hash table. Similarly, it is used to retrieve data from hash table. For example, here we consider the hash function as key mod 5. That is, the hash table has the size is 5. First step, we insert key 33. So what we will do, we take a mod 33 mod 5. We get some answer. Next one 54 mod 5, and third step is 25 mod 5. So based on that answer, we store the data 33, 54 and 25. So next one is indexes. A data structure that makes it efficient way to retrieve objects given the value of one or more elements of this object. That is, we call it a object, we call it as records. The records, we call it as one of the field of that record. So we can add, edit, delete, save and so on with the help of indexes. The index structure, they have two keywords. One is search key. Next one is data reference. Data reference nothing like the address of the primary key. Search key means can either a primary key or a candidate key. The value of the keys are stored in stored data, so that the corresponding data can be easily accessed. So next we introduce a MapReduce concept. The MapReduce concept is nothing like we will map the data, and we use the reducer task to reduce that file, and we merge that file together finally. So that MapReduce and the new software step, nothing but to distribute the data for processing to reduce the time. The files to be stored in the distributed way. For example, here we use two concepts. One is DFS. DFS is nothing like distributed file system. Next one is standalone file system. For distributed file system, for example, we use S3 and HDFS. For a standalone file system, for example, we use NTFS. So distributed file system will distribute the files. Standalone file system will not distribute the files. For example, here distributed file system, for example, if we have 1 GB file, it will split and send to another machine. For the 1 GB, for standalone file system, we have 1 GB file, we have split and send the data. There are several distributed file system. They are Google file system, Hadoop distributed file system, that is HDFS. Next one is Cloud Store. So in Google file system, nothing like the original data of the class. Next, HDFS means open source DFS used with Hadoop and implementation of MapReduce and distributed by the Apache software solutions. Next one is Cloud Store. It's open source DFS originally developed by Cosmos. It has two types. One is a physical organization of compute nodes and a large scale file organization. So the first one is a physical organization of computer nodes. This is organized in the parallel computing architecture that is also called as a cluster. Here, the each compute nodes are stored as racks. Racks means if we have, for example, if we have one data, we split that the data to multiple nodes. So in that multiple nodes, we have racks. The rack consists of eight. So we in that one box it has 1, 2, 3, 4, 5, 6, 7, 8. So 8 types. This is we call it as chunks. Each rack consists of chunks. So that is we call it as one node. So single rack are connected by the network, that is we call it as node. So one node has multiple, it consists of multiple racks and or many racks of compute nodes, and racks are connected by another level of network. They may be many more racks and many more compute nodes per pack. So here the compute nodes and interconnection network fails, the system will not be working at any given time. If the one node rack fails, the loss of the entire rack. Abort and restart that computation every time. If the one component failed, then the computation might never complete success. So for overcome this, we follow two steps. First, file must be stored redundantly. That is, if we did not back up the file at all and the disk crashed, the entire file will be deleted and cannot be restored. Next one, the computation must be divided into tasks. For example, if one task fails to execute the computation, it can be restarted without affecting the other task. This strategy is called as MapReduce programming. So next one is large file scale organization. In that it has two types. One, the file can be enormous and the files are rarely updated. So first one, the possibly terabyte in size, that is if you have only a small size, there is no point of using DFS. So next one is files are rarely updated, that means they are read as data from some calculation and possibly additional data is appended to files from time to time. For example, airline reservation file system, if the data is too large but they are changed frequently, so it is not suitable for DFS. Then files are divided into chunks which are 64 megabytes. Here the replicated 3 times at 3 different compute nodes. Holding copies of one chunk should be located on different sites, so it does not lose all copies due to lag failures. So next, to overcome the above problem, we introduce the concept called MapReduce. So before MapReduce, split the data and store the data into different machines and generate and find the data and combine to it. This is before the MapReduce introduced. The problem occurs during the process. Here, why the problem occurs means here the entire process will fail. All the other nodes also failed. To overcome the above problem, the MapReduce was established in the year 2003 by Google. For why they introduced MapReduce means to simplify the data processing for large amount of data. So large amount of data means the data in parallel or large clusters. Here we have two types. One is mapper and second one is reducer. The mapper means data is read and processed to produce one key value pair, maybe an intermediary output, to give the output to the reducer. What reducer will do means to aggregate the intermediary output. So this is the architecture of the MapReduce computation. So here if we have a data, so we use MapReduce concept. So we split the inputs into multiple chunks. So each box represent one chunk. So we have 3 chunks. So based on these 3 chunks, we group the input data by keywords. So then after grouping, we send the reducer task. The reducer task read and then combine the output together. So the map task means it consists of elements which can be any type. That is, it will be a document, or it will be a word, or it will be a tuple. The map function takes in the input elements as its argument and produce zero or more key value pairs. The keys are not keys in the usual way. They do not have unique. They have different keys based on the input. Rather, the map producer can produce several key value pairs with the same key and even from the same element. So how the grouping will happens? The grouping will happens by using the key value pair or grouped by keys, and the values associated with each key are formed into the list of values. So, for example, in input data, we have a three sentence that even we can as three word documents. So here first is contain bus, car, train. Second contain train, plane, car. The third contain bus, plane. So what we will do means we will map the document. So bus, car, train, plane, car, bus, plane. In first document, how many times the bus occur? One time. Next, car occur one time. Train occur one time. The same way, second and third. So we group the keys. Based on this grouping, in first, how many times the bus occurred? One time. Then the same bus where we occurred in a third word document, the bus occurred two times. So we group bus in together. Likewise, train, plane, car. So based on that, we reduce the task document. After reducing, what we will do? We combining all those together to get the output. So the reducer task, it is a pair consisting of key and its list of associated values. Output of the reduce functions is a sequence of zero or more key value pairs. The key value pair different from those sent from the map task to reduce task, but often they are same type. Combiners, the reduce function is associated and commutative. The values to be combined in any order with the same result. We use a algorithm by applying a map reduced functions. First, we used two algorithms. One is matrix vector multiplication algorithm. Next one is relational algebra operations. So contains two important tasks here. One is mapper, that is we call it as mapper class, and then next one is reducer, we call it as reducer class. For relational algebra operations, we use selection, projection, union, intersections. That are the relational algebra operations we used. So for that, first what we will do means we are applying a map reduce concept. For map, we split the data with the keywords. Based on that data, we combine together after the key values pairs are generated. So next one is extension to map reducer. They have number of extension and modification. The characteristics of they are built on DFS, that is distributed file system. They manage very large number of tasks. They incorporate a method for dealing with most of the failures that occurs during execution of the large scale. It has the workflow system, the experimental system called Clustera and Hyrax to extend the map reduce from the simple two-step workflow to any collection of functions with an acyclic graph representation workflow among the functions. An example of the workflow is more complex than the map reading. The next one is recursive extension to map reduce. It has many large scale, computational and recursive. For example, PageRank algorithm we studied detail about PageRank algorithm in Unit 4. Next one is computation means fixed point of matrix vector multiplication, and recursive means iterated by MapReducer jobs. So next one, trigger used when managing failures when implementing recursive algorithm. It views it as a graph. Each node of the graph corresponds to some task. Next one is the communication cost model, measuring the quality of the algorithm implemented on the computing cluster of the types. The communication cost for task networks, it is the size of the input to the task. The size can be measured in bytes and use relational database operations. It estimates the running time of the algorithm. Three ways to measure the efficiency of the algorithm. The three ways are: algorithm executed by each task tends to be very simple. Typical interconnect speed for computing cluster is 1 gigabit per second. Copy of the chunks on which the task operates. The chunk will be stored on the disk, and the time taken to move data into memory. Next one is wall clock time. The time it takes parallel algorithm to finish the each and every task. The work is divided fairly among the each task. Next one is multi-way join. Analysis of communication cost can help by following ways: selecting certain attributes of the relations involved in the natural join of three or more relationships. Select the number of buckets for each of the attributes. Identify each of this attribute with the bucket number. Send tuple for each relations. Next one is complexity theory for MapReduce. It is unique because it combines bound on time, space, and communication. Time means the total time available to processors is polynomial. Space and communication means a total space and communication are slightly less than quadratic. Some complex measures of MapReduce include reducer size and reducer rate, the graph model for a MapReduce problem, mapping scheme, lower bounds on replication rate.